much as you understand the principles and you try to make it work. But I would say that one of the top aspects in physics, everywhere you do stuff depending on how you see it. But the most voluminous aspect, the aspect that seems much, is mechanics. And it requires a lot of dependency. You know motion, you know equilibrium of forces, you know vectors, everything applied within mechanics. So that's why it used to look tough. What we just did on friction now, if you don't have some experience in motion, you might not be able to do it. Even if you don't have some experience in vectors, you might not be able to do it. However, I try to still explain it in a way that I feel if you follow, you should manage to understand it. So, we are still on mechanics. We have not done anything. I plan to show you some part of work energy and power which I can skip. I plan teaching you equilibrium of forces. Then after that, teach you pressure and density. Before I now move on to solar attachments, and you spend time on it. And I don't expect you to have good time with it. I taught you electricity. I spent time on electricity. Sam taught you waves and lights. And I think the scholar taught you part of atomic physics and your electricity. So I don't expect you to have problems. But let's say the mechanics, maybe P factorial didn't finish everything. But this, it did so many parts to the mechanics. Now, where are we moving to? We should do density and pressure first. Yes. Before equilibrium of forces, if time requires. Now, there's nothing much on density and pressure today, but the questions can sound technical. Now, let me start with density, and I'm not going to spend much time on it. We are just going to solve questions together. So, the first thing you need to know is definition of density. You need to know the definition. You need to know when you say density of the mixture, when you mix two substances together, what happens to the density. You also need to know that most times mass is constant for a body. Density and volume can change. You need to know that. So we define density as mass per unit volume. Abby, please follow this formula in level, which is equal to. Our mass is kilogram, volume is meter cube. So units for density is kilogram per meter cube. Now, water is said to be a standard substance. Density of water is usually given as 1 gram per cm cube or 1,000 kilogram per meter cube. So, don't forget this. Density of water is a constant. So that is the definition. I don't need to tell you more about Archimedes' principle. When you have objects under this topic, some objects are said to be regular, while some objects are said to be irregular. That means that some objects have specific shape. If I have a cube, mathematics students, what's the volume of a cube? N raised to power 3. All sides are equal. Abby. If I have a cylinder, mathematics.
No power. Please charge.
What will it? Engineer. It's not charging.
No power. Please charge. No power. Please charge.
It's not plugged. Engineer. See what they do?
No power. Please charge.
Engineer, I plugged it. I don't remember it. Oh, you called them. You push it. See what they do? But they're not holding up. But what's it?
No power. Please charge. No power. Please charge.
Assistant engineer, area. Big man. Assistant engineer. We are beginning.
No power. Please charge.
Engineer, area. What's it called? So, máa sọ fún mi ẹ̀yìn tí máa kò lè graduate pẹ̀lú promotion ó ti ń kọ kó lè tètè ṣe freedom. So, mathematics student, what's the volume of a cylinder? Is that correct? We need to know these things as physics students because you might need it under this topic. If they tell you that an object is a cube and is dropped in water, you need to get the volume of that object. If they just give you one side, so you need to know the volume. Everybody, what's the volume of the cone? 1/3. Is it per square inch? How about sphere? 1/3 per cube. So this is cone, this is cylinder. Let us just get used to these ones. And most times in jam, these are the ones, just cube. They used to like to tell you that you put a cube in water. Then what is the cube? For irregular objects. Now, these are the volume, which means that they give me a cone now, and they said I should calculate the density. I can determine the volume of the cone, then I can measure the mass, put it on and weigh it, then I'll determine the density. So all I need is this. Is that it? For an irregular object, you cannot measure anything like length. It's an irregular object is an object without a particular shape. So there's no way you can measure this. What you can do is to follow Archimedes principle. You take that object, you put it in a measuring cylinder or water and use a raker can to collect the liquid. So, for simplicity, let's say this is what we have. This is the normal level of the water. So I take that object. Please pay attention here. For like 1 week. Let's say this place is 50 cm cube. This place is 100 cm cube. I will take this object and I drop it in this place. One thing you will notice is that the volume will rise. And let's say the volume rose to that level. Archimedes made us to know that when you drop an object in the liquid, the volume displaced is the same as the volume of the object. Meaning that the volume of water displaced is equal to the volume of the object. This is very important. Which means that if half of the object is what is inside, that means that half is what displaced water. We are going to apply that later. So now if I ask you what is the volume of the object in this scenario now? You know it was initially at 50. Then when you drop the object, it rose to 100. So that means that the volume of the object here is 50 cm. Do you understand that? So now, I can just put this thing on weighing balance and I will know the scale. I'll just measure the mass. So let's say it gives me 5 grams. Then I can say 5/50. Then I'll get the density. Do you get that? So density will now be the mass you weigh on the weighing scale over the volume. So weight will be over 50. So that's by the way. Please, this is not the time to start talking. This is the time to give you 100% attention. This is just the formula, but when you start solving questions, you know that it goes beyond the formula. So it's what I'm saying now that you should listen to, so that when I get to some places, you will understand what I'm saying. Now, that is density. And you need to know that for substances of same mass, the higher the density, the lower the volume. Density is how packed together something is. So if they have the same mass, you know that density is inversely related to volume from here. And since mass will be the constant, so you can say density times volume is equal to the mass. Mass is a constant. So you can say rho 1 V1 equals rho 2 V2. So if they told you that a substance has the same mass, but you heat the substance up, then the substance can melt. But nothing problem. Who is that? Parents. One number one. Who want that? One more road here. Who want that? Oh Jesus. That is one more time. So you can't do that. Big man. Kò kí gbọ́rọ̀. Kí ló sọ? Mercy answer me, you are the person. Ṣòro àwọn kan náà rí àlùkòrè fún àṣọ́nà. So please, I pray that some of you, your parents can also come. You will get to you say that you gave for 12 hours class and you're just walking up and down. So can we move on, please? Please, it's okay. It's okay, please. Now, if you ever get missing here, if I ask you a question and you cannot answer, I will send you out. Okay, after I'm done teaching this, if I ask you a question and you cannot answer, I will send you out. And I will say that I don't want to see you again. So, we have what we call density of mixture. You can take two substances and mix them together. Let's say kerosene and oil. When you mix kerosene and oil together, kerosene has its own density, oil has its own density. They will now say you should calculate the density of the mixture. Density of the mixture is given as total mass over total volume. Is given as total mass over what? Total volume. So let's say I have mass of kerosene now. So let me call it M1 plus mass of oil. Let me call it M2 over D1. Now, mass of Emmanuel Apadawadu. We can also say that it's rho 1 is equal to M1 M1 can equal to 1 given. M2 can equal to 2 Just continue. So from here now we can have density of mixture to equal to rho 1 V1 plus rho 2 V2 all over V1 plus V2. So these are the important things you need to know about density. The next thing you need to know is Upthrust. Upthrust. Upthrust is also known as buoyant force. If you have a liquid, don't listen. Come on, but we don't time to answer questions. If you have a liquid and you have an object, and you drop the objects in the liquid, different things can happen to that object. One, it can be inside the liquid entirely. When it is inside the liquid entirely and it touches the ground, then you say that the object sunk. It can be inside the liquid partially. When you say it is inside the liquid partially and a part of it is up, you said it is, floats. Now, understand these scenarios. We will apply them in solving questions. The object floats, the object sinks. There's another one which can be suspended. But the difference here is that, what do we mean by Upthrust? Upthrust is the force applied in a simple term. Force applied by a liquid on an object. When immersed or when totally immersed. When immersed totally or partially in a liquid. Upthrust is the force applied by a liquid on an object when it is totally or partially immersed. These objects now are keeping it inside the liquid. Many of you would have noticed, if you have checked it before, if you go to water and you use your hand to press water, you will feel a force as if the water is also pushing your hand. That force that you feel that is pushing your hand back is opposing what you are doing. That opposing force is what we call Upthrust. As I'm dropping this object into the water, what will happen to that object? It will want to go down. Abi, what is bringing it down? Weight. Abi, as it's going down from Newton's law, so to say, what happens to the water? The water is also pushing it back. The force the water is applying on it to push it back is what we call Upthrust. Are you following? And equal and opposite. Don't listen. Just move outside. We don't want you in this class. and I'll send you out myself. Because this part now, irrespective. Now, the more I apply the force, the more it pushes out. But if I now apply greater force, then my hand will go inside. I'll bring that its own opposing force. It's just like you sitting on a chair. The chair is also pushing you. If you apply too much force, then you will break that chair and you will go down. So it's the same thing here. If the weight goes beyond the upthrust, what do you think will happen to this object? Because it will break the upthrust. I hope you are getting that. That means that your object will sink when weight is greater than upthrust, or when upthrust is less than the weight. Do you get that? That's why the object will sink. Density also talks about how compacted an object is. This liquid that is here, if this object is dense, well packed together, and the density is greater than that of the liquid, it will also sink. If the density of an object is greater than the density of the liquid, what will happen to that object? It will sink. You should know, an object of high density will sink. You should know that. If you have water and kerosene, one of them always floats, one of them goes down. Water is always down and the kerosene floats. So if they ask you in chemistry, why is it that the water sinks? It's because it has a higher density. It's not upthrust I'm talking about in that case now. The water will go down because its density is greater than that of kerosene. So an object with higher density will what? Sink. Are you getting my point? When will the object float? When the upthrust is greater than the weight. That's when it will float. It will float. That means that when the density of that object is also less than the density of the liquid, it will float. All these are things they can ask you in exam. Now that you understand upthrust, the one that is floating, what is now the problem? Let's look at it. Just let your mind follow. We'll solve questions. Now, the opposing force you apply is the upthrust. We now have what we call principle of flotation. From what we have said, principle of flotation states that a floating body, this body is floating a bit. A floating body displaces its own weight of the fluid in which it floats. This body is floating. How many times have they told you, if you take an ice block and you put it inside water, what do you notice in the water? At that time it will first rise, Abby. But when you leave the ice block, when the ice block melts, the level of water will remain the same. It will not pour, neither will it fall off again. But if the water is filled to the brim and you drop ice block, as you are dropping it, the ice block will be creating space for itself, meaning that it will displace water that equals its own weight. It will displace it and it will stay in the water. Then when it melts, it has already displaced its own weight. So by the time it melts, it will remain at that level. So this one is now stating that if the body floats, the floating body displaces its own weight of the fluid in which it flows. So before this guy will float, it must have, it's just like this. I have a liquid. This liquid is filled to the brim. Now, by the time I want to drop an object inside the liquid, definitely this liquid will spill over. Abi? Now, for the object to float, it must display some level of fluid as I'm dipping the object inside. Even though the liquid might still feel like it's fused to the brim, but some level of water would have poured out. Abi, as I've dropped it. But if this object can melt, by the time it melts, the water will not pour. It will remain at the same level. What did he do? He spread out his own volume in the liquid. So let's just take this as water now. As you are pouring it, the water you are pouring, the same volume will pour out. Do you get my point? It's the same thing for the object. As you are dipping the object, volume of this object will be displaced from here. So meaning that the volume displaced, you can just take it as volume displaced is equal to the volume of the object. Are you following? Are you following? Some of you cannot follow because you are not yet. But those that are following, please follow. Now, and I will neglect some of you. And if I see you talking when I'm doing some things, I will send you out. And I mean it. Don't see my red eye. That's if I have one. I don't know if I have a red eye, but I need to still warn you. Don't see my red eye. So from what we have here, the volume of the object displaced will be equal to the volume of the liquid displaced. Liquid displaced will be equal to the volume of the object. Let me ask you a question. There's an object. When this object is immersed in water, and it has the volume of that object is 200 cm3. But when it's immersed in water, 1/3 of its volume is outside the water. 1/3 of its volume, when it was immersed in water, 1/3 of its volume is outside the water. One over 3 of the volume is outside the water. It's just that sometimes I don't like calling people. It looks like I'm going to embarrass you, but sometimes embarrassment is needed because I'm supposed to call you if you have been listening to me. So everybody, if 1/3 of its volume is outside the water, what do you think is the volume that is inside the water? That means that if the volume of the liquid displaced or the volume of the object is 200 cm3 and 1/3 is outside the water and 2/3 is inside the water of that object, what is the volume inside the water? Just 2/3. 2/3 of 200 is the volume. Out of 200, 1/3 is outside. Then 2/3 will be inside. 2/3 of what? The volume of the object. This is why you always have problems in solving density questions. This is why. Because the moment you can't talk about the fractions inside, fractions outside, the questions will look complicated. So, if 1/3 of the volume is outside, 2/3 of the volume is inside. That means if I want to say what is now the volume inside, that will be 2/3 times 200. You understand that? Basic mathematics. So if I start solving question and I put this, you don't say that where did we get it? I hope you are getting bits of light. Whether it's clear or not clear, you are sure getting light. What is up with you? Go back. You just miss one point like this and you start over again when you come to this aspect. And I'm not trying to teach you like just give you definition. Now, Upthrust is the force applied by liquid on an object. And that force applied is gotten by the weight of the object in the liquid. If the weight is equal to the Upthrust, it will be suspended. If the weight is greater than the Upthrust, it will sink. If the weight is less than the Upthrust, it will float. Now, when it floats, a part of it will be inside water, a part of it will be outside water. But the principle of flotation is now telling us that if an object floats, that object that is floating will displace its own volume. So if whatever makes it float, that part that is putting inside the water will spread out. If they fill water to the brim and I step inside, I'm going to displace my volume inside that water. So if you say, what is my volume? Just go and measure the water I spread out. That tells you my volume. That's what this part is saying. By the time I step inside water, everything about me will push the water out. Then if you now say, what is the volume of that guy that steps into the water? Take the entire water, go and weigh it. When you know that, then you already know my volume. So a floating body displaces its own weight. What are you displacing? Its own weight. What is it displacing? It has a weight. It's going to displace, but what is displacing is in form of its own weight. My weight now, when I stepped into water, water will spread. So what did I displace? Is it my weight I displace? But my weight is the one that is displacing something. Do you get that? So a floating body displaces its own weight of what? Of the fluid in which it floats. So you are displacing the fluid, but using your weight. That's the English. I don't know if you understand what I'm saying. It will be clear. Now, that is principle of flotation. Archimedes' principle now states that when an object is partially or fully immersed in water, it states that when an object is partially or fully immersed in water, it experiences an upthrust. When an object is partially immersed in water or fully immersed in water, it experiences an upthrust. And that upthrust is equal to the weight of the liquid displaced. When an object is partially or fully immersed in water, it experiences an upthrust. The upthrust is equal to the weight of the liquid displaced. Now remember principle of flotation. A body displaces its own weight of the fluid in which it floats. Archimedes is now saying that when you put that weight, the body is going to experience an upthrust. That upthrust will be equal to that weight we are talking about here. Now let's go back. When an object is partially or fully immersed in water, these are the two scenarios. When it is partially immersed in water, when it is fully immersed in water, it's going to experience an opposite force, like what I explained here. And that force is called upthrust. But that upthrust will now be equal to what? The weight of the volume displaced. So you now say that if I put an object inside water, let me put it this way, so that you understand it. Let's say this is volume of a liquid, and I'm dropping an object in this liquid. Then I open this container and I collected the liquid. So listen, by the time I drop this object, what will happen? Some of the liquid will fall here. As you drop it, this guy is weight reacts downward, right? Then the water will push it back. That force that is pushing it back is called what? Upthrust. But as you drop it, it will displace water. Archimedes is now saying that the upthrust you get in the water is equal to the weight of the water you pour out. Which makes sense according to the principle of flotation. So it's stating that upthrust, when a body is fully immersed or partially immersed, the upthrust of that object will be equal to the weight of the liquid displaced. Now, what is weight? Mass times gravity. So I can say that upthrust is equal to mass of the liquid multiplied by gravity. Now, that weight of the liquid displaced, does it equate to the weight of the object? You need to answer that. Does it equate to the weight of the object? Yes, according to the principle of flotation. So I can still say that upthrust is equal to mass of the object multiplied by gravity. I hope you are listening. But without that, let's move on with this one first. What is density of the liquid? Is going to be mass of the liquid over volume of the liquid. But it's not the entire volume of the liquid. If this liquid was 200 cm3 and 50 cm3 was displaced, will I use 200 here? When you are not listening. And that's where some of you have issues with. So, mass of the liquid now is going to be what? Density of the liquid multiplied by volume of the liquid. Do you believe that that volume of the liquid is the same as the volume of the object? Because as you drop the object is the one that displays the volume. So if I now say from the question I asked you that 1/3 of the object is outside, that means that the volume of the object inside is 2/3. That means what I will use in my calculation here will be 2/3 of the volume. I can't use 1/3 of the volume because what displaced that water is 2/3. I'll give you a question. So now from here we can now say that we already have the mass of the liquid. So we can say density of the liquid multiplied by the volume of the liquid multiplied by G. So upthrust is going to be rho Vg. Rho Vg. Now, your rho can be the density of the liquid. Your volume, is it the entire volume of the liquid? No, get that right. Your volume is the same as the volume of the object. If it is fully immersed, that means it will be total volume of the object. If it is partially immersed, that means it's only that part that is inside the water that is the volume. Are you lost there? Don't get lost. Think about it. This volume is the volume of the liquid displaced. But if I say volume of this object is 200 and I drop it in the normally if I say it's 200, but I now say when I put it inside this place, only 1/3 of the volume is outside. That means 2/3 is inside. That means that 2/3 is what to be displaced here. That means 2/3 of 200 will be the volume I will use in my calculation. Do you get the point? So now this can be density of the liquid, volume of the objects, and gravity. So I can say volume of the objects is the same thing as volume of the liquid displaced. Not just volume of the liquid now, but volume of the liquid displaced. So just remember that upthrust is equal to rho Vg. Common question in JAM is this. They will just ask you to calculate your trust. But if textbooks want to make it tough, they just start putting fractions. Can we move on? That is one condition. Another condition is this. If I now have determined your trust in the water now, remember, please. Another term we want to look at is what we call, I think apparent is double E. Apparent weights. Your questions will not be that tough. The formulas you need, I will give it to you. Just understand this. We're not that issue. Now, just listen. Why are you not sitting here? What's your surname? Olawi. You didn't see space, so I've been sitting there and they are hiding behind the wall. I'll do them one day, one more shaky. Oh, in your room, I told that father. I told your work on Saturday. Anything about the possibility is not part of it. Anything about it, you don't find that out. That's what you have to do. And when you are here too, you're always passive. But I hope God will help you soon. So, I know most of you listeners. Some of you too, are just always like this. I can read your mind, and I know your story. I see what you're going through. How was it? You cannot make it. You can never make it. Oh yeah. Don't worry, after this class you will enter studio. How many of you can sing? Don't worry, I don't understand that thing. Who has sing what song? I know that she will sing for that. Let's move on. Let's move on. Now, the Upthrust is equal to, do you understand this to this level? So if the question is talking, you will know what the question is saying. They know something. When an object is floating, a part of that object, we said something. We said if an object sinks, what is the relationship between the weight of that object and the Upthrust? The weight is greater than the Upthrust. So, in some cases, which the common analysis they give you, when you are fetching water, and the water is filled, and you are pulling it out, why the fetcher is still inside the well, inside the water, it uses lights. Even though when you bring it out, if it's heavy, which is that actual weight. But when you put it in water, it feels a bit light. You are still feeling something. The major reason it feels light is because water is helping you to carry it. And that water helping you to carry it is the Upthrust. Now, when you pull it out, why are you doing as if it's a Yoruba movie I'm doing? Now, Now, what you are supposed to learn now, you know them. Let's say, please listen. Let's say this rope, the extension in that rope. This guy has a weight inside the water, but you are not really feeling much tension because when it's inside the water, it feels light. But when you pull it and it is up around here, then it feels very heavy. What it weighs when it's outside, we call it the original weight. When the object is in here, we have what we call the original weight. That is the weight in air. Follow. When it's inside the water, you are feeling something, which is the tension in the rope. That, when it is inside the water, it's experiencing upthrust. And that upthrust can be equal to the weight of the liquid displaced. But as it's inside the water, the only thing is it feels light, but you are still feeling something. That force that is helping you to keep it up so that it feels light to your hand is what we call upthrust. Is that taking? So that is the buoyant force. Now, while it is inside the water, it feels a bit light. Then, that one you feel when it's inside the water, that force you feel, which most times is equated to tension, is called the apparent weight. Now, let's do it together. Let's say that an object in here weighs 50 grams. Please listen. When it is inside water, it weighs 10 grams in your hand. What is your trust? When it was in here, it weighs 50 grams. But when it is inside water, it weighs 10 grams. Then that means that what will be your trust? Upthrust is helping you to carry it. So that 50, you are no longer feeling 50. You are only feeling 10. That means upthrust is doing the job of 40 for you. So that 10 you are feeling, what will you call it? Original weight, apparent weight, or upthrust? Apparent weight. Which means that this formula, original weight, equals apparent weight plus upthrust. Is that formula correct? Yes. Do you understand this? So, what is your apparent weight? The weight you feel when the object is totally or partially immersed in water. If it is partially, you can determine the upthrust based on what we have said here. If it is totally, you can determine the upthrust based on what we have said here. But you will be given what to do. Then here now, I can say that the upthrust is equal to the weight of the object when it is in the air minus the weight when it is inside the liquid. You know why I say weight when it is inside the liquid now? That's the apparent weight. I don't want you to misplace A for here. Do you get that? Can I change the A to A now? Apparent weights. You can see it as A or L. Which means that the weight you feel when the object is inside the liquid, the weight you feel when it's inside the liquid is not the same thing as upthrust. The weight you experience when it is inside the liquid is called apparent weight. The weight the liquid exerts on it is called upthrust. Do you get the difference in the English? These are the things you see in questions that get you confused. Because even as I'm saying it, some of you are still bragging, trying to balance the thing I'm saying. Now imagine that you are the one seeing questions and they are saying weight of the liquid of the object is beside and dispersed and 10 grams. I don't know for you, I hate my leg. Please, do we understand this formula? The Upthrust is equal to original weight, that is the weight in here when it is low in water, minus the weight you feel when it's inside the liquid. In many cases, they use that weight to feel as tension. She gets, and just using different letters to represent it. They will tell you the tension when it is inside the liquid is this. Know this formula. It will be useful for the rest. Can we move on? Now, before we move on, let's introduce Upthrust. So let's say only a fraction of the object is immersed in the water. And our original weight is going to be apparent weight plus Upthrust. Abi, Upthrust is density of the liquid, volume of the liquid displaced, which can be the volume of the object inside the water. It does not have to be the entire volume of the object, it can just be a fraction that is inside the water, multiplied by G. Are you getting it? So now I can say the weights, the original weight can still be written as apparent weight plus rho L, V, L, or G. Your VL can still be representing as V objects. She gets. To some extent, I think that's okay. Let's move to relative density. So now that you understand all these principles and you can think about it, we will apply them in solving questions. But let's quickly define relative density. Relative density is just an experimental case. Relative density is also called specific gravity. And we use it to compare densities of a standard object. And the standard object we usually use is water. I want to know the density of an object, then I want to relate the density of an object, the ratio of that density to that of water is what we call the specific gravity. So knowing the density of a substance in relation to a standard density, that is specific gravity. Relative. I want to know the density of iron in relation to the density of water. I want to know the density of mercury in relation to the density of water, relatively to that of water. Báwo náà ṣe síra wọn sí? We call it specific gravity. So relative density. What's the instrument you use to know relative density? In the laboratory. It is hydrometer. Relative humidity is hydrometer. The one that has water is actually hydro. The one without water is hydro. Relative humidity is what? Hygrometer. Is it hydrometer? Hydrometer. You know relative humidity? Humidity is water. Abi is the one with hydro. It's not the one with hydro. The one with water is not the one with hydro. Except I forgot it. That's how I used to remember when I was really there. Because there's tendency to be more around. So relative density is now what? Hydrometer. Hydrometer. So relative density, it now depends if I'm talking about solid. Relative density of a solid is equal to mass of the solid over mass of equal volume of water. And most times when they are saying mass of equal volume of water, when you are relating this, there's an instrument to use for this process too. In case the solid is powder, we use an instrument called density bottle. Density bottle. So if you want to determine the relative density of the powder, you use density bottle. That's the instrument we use. So just know the mass of the solid over mass of equal volume of water. Another formula for density of heat. Relative density of solid is equal to density of the solid over density of water. That's another formula. Are you there?
Yes, sir.
Thank you. Relative density is also equal to density of weight of solid over weight of equal volume of water. Is that thinking? So finally, relative density of liquid. If they say determine relative density of liquid, relative density of liquid can be density of that liquid over density of water. It's not Vura. Relative density is also equal to Upthrusts exerted by the liquid. Upthrust exerted by the liquid on an object over upthrusts exerted by water. Now I want you to note this one. This one is a common one in exam. It comes out every year. So just note. You remember upthrust, Abby? Let me explain how the questions here always look. They will give you a liquid, maybe kerosene, and they will give you water. They will not say that determine the relative density of kerosene, but they will give you an object. That object will be inserted in liquid. They will tell you the weight of that object in here. Then they will tell you what it weighs, or you will determine that yourself. But most times they tell you what it weighs. When you know this one, W is apparent weight. I mean, this one is original weight. So they will give you with the weights in here. Then they will give you the weights when it is inside kerosene. They will also give you the weights in here, which is the same. Then they will give you what it weighs when it's inside water. Then what will be the upthrust here? Upthrust here in that liquid is going to be weight in here minus weight in that liquid. Do you agree to that? We just did that as a parent. That's what we just did. Oh, they consider me and all. Upthrust in this case, now upthrust in water is going to be what? Weight in here minus weight in water. Which means that this formula can be reduced to relative density of that liquid, which is equal to upthrust in the liquid over upthrust in water. Abi, what's the upthrust in the liquid? Weight in air minus weight in the liquid over weight in air minus weight in water. Do you get that? And in many cases, they might not use weights. You don't even need to convert it. You can still say mass in here minus mass in liquid over mass in here minus mass in water. So I think let's solve questions on this. Thank you. We are your past question. Let's see how it's going. So I will now quickly teach you pressure. There's not too much of pressure. Quickly know that they will now do equilibrium of forces. Then after that, we move on to heat and temperature. Then after that, we move on to waves and lights. So I'll teach you basics. I will teach you critical angle. Then we'll now move to electricity. Then we'll move to magnetism. You people say that this is Can we solve now? Oh yeah, please, so that you will not be scared in exam. Most times questions on densities in JAM, there are questions you can solve. There is no question you cannot solve. But if you prepare for physics with tension, you might not just do it. It's not that. Oh yeah, number one, are you there? Are you writing? It's no longer going. It's not going. So listen to this question. Someone said that what if the object was dropped with force? The liquid is placed to be higher when it is dropped normally. So in that case, what will happen? The same force that used to drop it is the same force it used to store your eye. It's the same thing. The guy displays more than its volume. So it's the same thing you will still get. If you like force it, highest is it just a sudden push will make you spring over. And that's the only thing. Sir, please let us do nice class. So we cover all the topics. Thank you, sir. Those that want to stay will stay. You can't stay, you can go. I want to say this. If you don't get it, just wait to be suspended. So please, as much as possible, I would have loved to start on this thing from the beginning. That they are shade of that but Yoruba will say that Omunika Jerope Egun Onfamo Oje Oje. Number one question. So for those online, the density of a solid is defined as the. Are you seeing it? A lot of you here don't have past questions. If someone thinks about some of your behaviors, then you need to discover it. Because how do you come to this class without past question? Before you even buy the school, number one thing you should buy is past question. That's the number one thing. When you go out with textbooks, you can see what teachers teach you. But questions are important to your life. So what's the answer to number one? So that is the mass per unit volume of the solid. So the density of the solid is defined as the mass per unit volume. Number two, a solid suspended, have you seen it? A solid suspended by a piece of string is completely immersed in water. A solid is suspended by a piece of string. It is completely immersed in water. On attempting to lift the solid out of the water, the string breaks. When the solid is partly out of the water, this is because so they are talking about you here. So a solid suspended by a piece of string is completely immersed in water. On attempting to lift the solid out of the water, the string breaks when the solid is partially out of the water. Why did the string break? If the tension in the string decreases as the solid is lifted, with the tension decrease, B, the mass of the solid has increased. Can the mass increase? The mass remains the same. See, the solid apparently weighs less when completely immersed compared to when it is partially immersed. Yes, and that's why it breaks. Is that clear? Number 3, number 14 for remix. The density of 100 cm cube per mole was 0.9 gram before frying. If the density of the oil was this after frying, assuming no loss of oil due to speeding, its new volume will be what? You understand that, Abby? Why they say, look, it will not, I told you that if the mass is constant, density will be inversely related to volume. So you can say rho 1 V1 equals rho 2 V2 when the mass is constant. So you know the density and you know the volume. Now, you know new volume calculates the density. Can we move on? Can you solve that? Very good. Number 4. An object of mass M and volume V is totally immersed in liquid of density P, of density rho. The tension of a string holding it is what? Can you do that? Go ahead, try it. And let me know what your answer is. If you can't solve it, so I can solve it for you. Let's see. Let me to get water. Cold water. Rowan is signing. That's how I used to say it when I go to say pure water. Ice water. At the Hausa place. Timati give you so they say I should say Rowan is soil. And that's how Hausa. It means buy ice water. is nice water we used to pour it there to get the sun. Omini on nylon. Shape of a nylon come and go to see. Some of you don't know that. If I'm at you, see white nylon, I'm going to see which. I want to money is relative. If I want to see my man with pure water, or my man with my ear, I want to kill them. I want to know rise on them. I want to kill them. Oh, you want that one? Have you solved it? What's the answer? C. Is C correct? Okay, let's move on. Have you all gotten it? Are you still solving? Should I solve it for you? Okay. So that they said objects of mass N and volume V is totally immersed in a liquid of density rho. The tension of the string holding it is when you put it. Now, I told you something when I talked about apparent weight. I said original weight is going to be equal to apparent weight plus upthrust. So when you totally immerse it in water, the weight you feel outside is the tension. That's what you feel. Are you following? When you totally immerse it in water, the weight you feel outside is the tension. And that's why I said that can also be referred to as the apparent weight. Now, what will be the apparent weight? Apparent weight, which is the tension, is equal to the weight in the air plus the upthrust. What will be the weight in the air? Mass times gravity. What's the upthrust? Rho VG. So now, something is common. Oh, sorry, I'm not. Don't make that mistake in the exam. So we cannot bring G outside, We cannot go to have A minus rho V, and that will be equal to the tension. Do we understand this now? Do we understand this? Except you were not listening when I was explaining. But if you still have a question, now you can ask. So, when it was in here, this is the formula. In water, that's the tension, upthrust, the force acting on it. So at the end of the day now, you can say that tension, making tension the subject of the formula. Then this will come here because W naught minus U. Then you can say T is equal to Fg minus rho Vg. Because we got upthrust, then G will be equal to F minus rho V. And that will be us out. Number what now? Someone said, but tension is the force in the roof. Why is it equal to the apparent weight? What will make the rope to cut is the tension. When it is outside the water, that tension becomes the original weight. But when it is inside the water, the tension is the apparent weight. It is the rope that will be feeling the weight. That will, as you pull the water out, the weight will be pulling the rope. and the rope will be stretched. So your own muscular pull and the water pull will make this rope to be stretched. So it is the tension that is the apparent weight when it is inside water. Can we do the calculation in atomic physics? No problem. We can, if you have time. We can read pressure. You people can read pressure. Pressure is not, being pressure. Pressure in the liquid. But should I stop solving it? Do you want to go and solve it? So I can quickly explain this. Oh yeah, let's solve number 5. Now, because number 5 is always asked, I want your mother come. Enjoy the game and go there. Some of you now, I'm sure, sorry. Because some of you don't know anything, and you are supposed to listen. Little by little, no man moderate. And then you told to more, come out to over what to do more there. And you are friendly. Now, I have a lot of people that since like 4 years ago, it's not because they are trying, they are not trying, but they have not still entered school. They wrote to ahead, they failed you ahead. They wrote down, they failed. They were not trying, but they just write the exam every year. Go back to the next year, they never to try again. Just writing, not prepared. They had the opportunity to come to primers once, just 1 month, 1 login. Up till now, they are going to school, they are not doing anything, but they keep writing the exam every year. They are not saying that I didn't think that they serious since that 4 years ago now. If not, it's like graduate, push the mama along, you have to pay 9 years for the probably 9 years, then I share one out. I've misused my opportunities when I had it. Because some of you have opportunities, you misuse it. Some people are praying that they see someone that will sacrifice time to teach them like this and stand and teach them. Sometimes we are not supposed to care the way we care. We are not supposed to. Don't you like to marry? Do you have many tutorials we'll be thinking that will come on for the syllabus? But sometimes like this, I will even skip instead of dreaming about my own. Instead of dreaming about my own life, as primary students, I'll be thinking about that. How will this student do well? How will this student do well? Whereas many people chose not to do well. They just chose it. You are the one stressing yourself. So that is the thing. But so let's see. Normally, if I do not come, you will do your normal Monday to Friday. Go back to the next week, you do whatever you want to do. Pass. I don't have to be here today. But my being here is because I'm still thinking about you. And some of you now still come here and wasting the effort. Do you think that if I say that if you are coming for today's class, you must bring 1,000? If you will not come, you will not come. But those that will come and bring it will come. And you will pay. You people are over 300. If I say 2,000 per head, if you are not coming, don't come. Do you know how long I've been standing here? I'm supposed to collect the money, go outside, go back and give jail, anything. If I take 2,000 come for one of you on Saturday, that's 600,000. You don't know what that 600,000 will be in my life. But if I organize it, you normally have your own class. Monday to Friday, that's what you paid for. So Saturday is optional. So if I decide to still put money on it and let people come, people that will come, and they will still pay. But sometimes you will not think about money, you give everything for free, and you just be misusing it. My first year around 1828. Why are you taking me back to olden days? Ṣé tọ́lù wà ní ìlú? So we can go to so number 5 is the question that comes out every year. And that's what I explained at that time. So you have asked a solid weight 4.8 grams in the air and 2.8 grams in water and 3.2 grams in kerosene. The ratio of the density of the solid to that of the kerosene is what? When they say density of solid to density of liquid, that is talking about what? Relative density. And that is that I can use the formula that says that mass in the air minus mass in the liquid over mass in the air minus mass in water. And that will give me the ratio. Is that okay? Please, as simple as you see this, you will see it in the exam. I promise you. Number 14. A uniform cylindrical block. Have you seen it? A uniform cylindrical block. A uniform cylindrical block of wood floats in water with 1/3 of its height above the water level in liquid. Relative density is 0.8. What fraction of its height will be above the liquid level? They said a uniform cylindrical block of wood floats in water with 1/3 of its height above the water level. Then in another liquid with relative density 0.8, what fraction of its height will be above that liquid? So what do we do? Can we know the density? I don't want to say density of solid. Okay, we can know the density of the liquid. When it floats in water, we can know the upthrust. Then we can equate that upthrust to the new liquid and now calculate the height of the liquid. I think we can do that. Let's try that. I set it out.
Sister Cheryl, please your cup.
So the height of that block, 1/3 of its volume of the cylinder. 1/3 of its height. 1/3 of its height is above water. That means 2/3 of its height is inside water. So how will I get the upthrust? The upthrust will be, that's what? Density of water, multiplied by the volume inside water, multiplied by G, right? So I can say that density of water, let me just use gram. So let's say 1. So the upthrust on that solid, on the wood, is equal to density of water, volume of water times G. But remember, 3/8 of this, 2/3 of this height is inside water. But volume is what? Area times height. Abi? So I can still say the density of water is 1 multiplied by volume of the whatever it is. I don't even want to care about the other thing. I can just say that that is 2/3 of the height. That represents like the volume. I can say times area. Abi? So please listen. So over 3 of the volume for now of the height times the area. That's still giving the volume. Abi? Do you get that? So now times G. Now I already know the upthrust of the objects. They now say when you put it in liquid of relative density 0.8, what fraction of its height will be above the level? So we need to know the fraction in the liquid. Abi, we already know the upthrust. So the upthrust is going to be density of that liquid multiplied by the portion of its height inside the liquid, inside, multiplied by G. Abi, you know, the portion of the height times A2. But A and A will still go later, whatever it is. Abi, since it's the object. Then I can equate the densities. So I can say 2/3 of that height times A times G is equal to density of the liquid will be 0.8 times what? We are still using 1. We are supposed to multiply by 1,000. But if we multiply by 1,000, that means this one too would have been 1,000. So we can still leave it as 1. So we can leave it as 1. Then that can be multiplied by X by G by G. Of the heights. So that means that 2/3 of that is equal to 0.8. So X is equal to 2/3. Is that correct? So 3 times 0.8 is what? So this is the one we have in the liquid now. So how do we now? So about 2.4. I don't want it to be a decimal like that. Divide 2 by 2.4. 0.68. So 0.68. Let's say everything is 1 minus 0.68. We are divide those options and see which one is 5/6. That means you got for this one, so about 2.4. They said we will get the fraction outside, not inside. This is the one inside, Abi, of the heights. So 2 divided by 2.12 is what? Then that's 5/6. That means it is 1/6 that is outside. Do you get it? Do you get it? So that's it. So the answer is 1/6. What you can do is divide this one divided by 2.4. Then that tells you the fraction that is inside the liquid. Then now to know the fraction that is outside, then subtracts it. So, but it's because we use I don't really know what to abuse here. How can I write, math students, how can we write this in proper fraction? So over. Please. Now this is 20 over 24. And that is 4 in 20 is what? 4 in 24 is what? So it means 5 over 6 of his height is inside water. So what will be outside? 1 over 6 is outside. Please, do you understand this? Do you also have any question on density? Please, just understand the principles I told you. Please understand those principles I told you. You will realize that it's very simple. Follow those principles right. It's very simple. It's very simple. The problem is just that how do I get fraction? Fraction inside, fraction outside. Let's see, explain. I already explained it when I was talking. So any other thing? Is it equilibrium we should talk about? Yes. Let's talk about equilibrium of forces. So when we are through, if there's any question. Can I rock the board? The question says that the fraction outside shall want to show you. You got right. It's okay, it's okay. Please, the same way you did say, when we did Upthrust, if you can practice based on what I just said, it's very simple. Please, let's do equilibrium of forces. It's also very simple. But for equilibrium of forces, we need a bit of knowledge of vector. But even if you don't know vector, let's shall wait to understand this. Are you following? So, when you go for your exam, don't forget, to send me your results. I want to believe all of you have my numbers now. How many of you have my numbers? All of you that deleted my number. And then you can block me now. You are coming to enter. You block me. Please, these are the things I want you to do for me. This is my number. Dr. Sonia. So listen, these are the things I want you to do for me. Number one, how many of you are going to UI? You are going to UI. How many of you are going to win? How many of you are going to Unilag? Immediately after your job, you are going to immediately after your job, we are going to host the event. We host it with you, and we also host it with your parents. How many of you are going to Badopoli? So listen. To those of you, it's okay. But we can be mature. Be mature, you last more, you keep quiet. That's why some will not want to joke with you. Because people back you. Last more, keep quiet. A lot of you will still decide to go to QC, voting, voter, you will see. So immediately after your job, when you see your results, we will post the webinar. Before you see your results, go and eat very well. Enjoy yourself. I don't want you to shout. Hey! It's okay. Please. Can we keep quiet? Please. For whatever I say, don't stay quiet. Even if it's quiet as you are. Since you don't have common sense in that, so please keep quiet. Please. I just want to address you so that I can move on to what I'm doing. Please. Immediately after your job, whatever school you are going to, please, let's stop talking. You are wasting time. How many times are we going to say let's stop talking? I will say what I want to say and we will stop the class. Because you are wasting time. Some of you, that's why they are about to give up on you in your house. Because at tomorrow, I want to come padlock it here. Please, Let's keep quiet. When we say anything funny, you laugh small, then you keep quiet. You don't have to laugh and start continuing laughing. Anybody that continues laughing is turning to like a mad person. So please, for all the post-UTME candidates, either you are writing post-UTME or not, we are going to host a webinar for you to talk about the results and everything at schools to carry you along. So don't be shy. Don't because of whatever you score, run away. We still have to find solutions together, irrespective of what you score. The thing is that I met someone, and for a very long time, the person has been shying away. Now, for almost 4 years now, the person came to primary and maybe admission did not work out. But to come back or to say that I'm shy, for almost 4 years now, admission is impossible, and you are still shy. It's better you score 180 and you talk to people that can help you. And you look for, if you want to go to school, I used to tell students, 180 will get you admission. But don't get 180 and come back and say medicine or nothing. If you get 180, I can help you process admission. Not like I will do fraud and do admission and enter. Most students, you can enter on merit even with your 180 if you process it well. But always listen when we give you instructions. Then when your mommy say, don't worry, 180, I'm the friend of the provost, and I know a friend that knows a friend that knows provost, don't worry, that 180 you get us. You will just say, mommy, thank you. You can go and continue processing it. Let me go and be reading for another time. If that one enter, fine, I will go. If it does not enter, let me face my jam. It's one of the reasons many people waste like 4 years at home. Because they will promise them that they will do the admission for them, they'll talk about them. They will resume school. They met some people, or friends would have resumed school. They would have done matriculation, and they will still be saying, man, worry, where my dad is said. Mama, she tests. Man, worry, I don't know my dad. They were not my job was I knew someone that did that the new jam for the next year closed. The person did not pay for it. They were saying, don't worry. So at the end of the day, no admission the previous year, no admission the following year. The person had to wait for another like 3 years. So please, just know what you are doing. If they are helping you for admission, I don't know about it. And you know your results cannot make merits, let them continue the help. I'm not saying that help, we are in Nigeria. I'm not saying that help does not exist. Help not exists, not fraud. So, but if you know your score, it's better, if you know that is the course you want, it's better you go and start preparing.
Is it, can the webinar be live?
Yes, it will be online. That's why it's webinar. It's web. It's online. So, it's going to be online. So if you're on the WhatsApp group, you can message me, then I will add you to the WhatsApp group. If you are not here, we will let you know later. We will do a flyer about the webinar. We will do for all these schools. So now, what you should do is that make sure you don't start putting your mind at rest. But if you come to me and you score 180, I will tell you all the schools you can go and the courses you can study with that 180. And we can now travel to the school to process the admission if you want to go. But if you bring 180 and you say, Sodium, I will give you any amount, let me shall make no sense. I don't collect any money for admission. I will just give you advice on what you can do. Please, know what you are doing. That's one. We'll talk about that later. Then, another thing is that during the post-UTME, by God's grace, I will be coming around to take some classes too. But most importantly, don't forget all these things we have done. Because you don't always have enough time to prepare for post-UTM. It's always 2, maximum 3 months. Maximum. And you have to do advanced work. And so if you don't know all these basics, it's always difficult for us to teach. Because I'm supposed to just come, teach you all the advanced parts. Why I revise this, I'll just say, do you remember? Then I'll do the advanced parts. Then we keep solving questions. Please, don't joke with that. When it's time for post-UTM, I used to say that if you know someone that is writing JAM for 2027, tell them to resume post-UTM class with you. Reason for that is that it will build their own background before they start their own JAM class. It will help them. During JAM class, it helps them to catch up easy. Then, number 2, those online, even if you are from Enugu, you are from Adamawa, you are from Adamawa, you are from Katsina, there's hosted, just come around. If you are writing UI, all those schools that are federal schools, come around for post-UTM class so that we start together. There is accommodation for you. So, come in. Then, immediately after JAM, how many of you are already on the foundation group? On the foundation group. I know some of you have sent money, some of you are yet to. Even if it is 500 naira, please, before we start this JAM, we want to make sure we already have something on ground. There was a primer student that sent me, you saw the results I sent on the group. It's one of the primer students. He has 5.0 CGPA. That's the one I sent. Okay, I only sent it on the foundation group. I didn't send it on the home group. He has 5.0 CGPA. He did not have any B at all through the session. So, someone like that now, we are supposed to give him something to encourage him. But we already said to start with your sets, not their sets. So, it's one of the reasons for the foundation. If you are here to join the foundation, please message me that I should add you to the foundation. If it is just 500 naira, you can give every month so that we have the next privilege. Or the children that want to go to school and they don't have money to go to school. Please, you can do that after your JAM. Then, make sure you send all your results to me. Then all of you, so what are the things I say you should do? Join foundation. And you can encourage your parents. We want over 2,000 people. If we have 2,000 people and they give us 500 every month, it will go a long way. It will go a long way. And you can see when they are paying the money, they are writing their names, Abby. So writing names makes it accountable. So at the end of the month, you know the entire amount that enters. So you can also follow. And when we give it out, the person that will need to also come and talk the amount that is given and everything. So it's transparent. I'm also going to be contributing every month. So please, if you don't have a phone yet, I say you can pay to your class reps. You can write your full name and everything. Then later when you have a phone, you will join the group. Then before or after your admission, before JAM starts again, we will have a conference. Then at the conference, we will determine many things together. So that's that. Number 2, if you are watching online and you are not watching, if you are here to subscribe, if you are watching online, just you see subscribe button, just click on it. That's what we need from you. Please, just click on subscribe so that we can go on to promote it. So after exam, you can go and subscribe. I'm working on so many things that will be beneficial to us. So let's move on to the equilibrium of forces. I pray that you will all do well your job. Yes. You will not. So we are here to go into the primary foundation. Just let me know, I will go to the foundation field. So all your efforts will not be in vain. It is next week that determines everything. Even if it is for you to lock in so 4 hours, just lock in and be ready. Before the so please, as much as possible, let's keep quiet now. Please. So we want to quickly talk about equilibrium of forces. Equilibrium of forces is also simple. There's nothing that is not simple. The word equilibrium means balance. So forces, we already said a body is said to be in equilibrium when it does not change, Abby, from what we said in chemistry. Let's apply it to physics. The body is said to be in equilibrium if it does not change its position, if it does not move. Some of you are talking and you are still disturbing in place. The body is said to be in equilibrium when acceleration is 0. Definition. If you hear that body is in equilibrium, most times the acceleration is 0. A body is in equilibrium when it's moving at constant velocity. The velocity is not changing, and that also means the acceleration is 0. A body is in equilibrium when it does not rotate, and that's what we want to talk about here. When the body does not rotate, it just remains in its position, then we say that it is in equilibrium. But there are a lot of things we talk about here, and we want to focus on physics, forces. And all the forces we will be talking about, they have what they do. You don't want the body to rotate, because that's one of the things about force. Force will make a body to move. If I push a body this way, I'm applying a force. If I apply a force of 20 Newton, if I don't want this body to move, I must apply another force in opposite direction, 20 Newton. At the end of the day, this body will not move. Please, can you hear me?
Yes, sir.
That means the acceleration of this body is going to be 0. Abby, it's not going to move. There is a force here, there is a force here. But those forces, they are in what? In equilibrium. This is just a simple analogy. I can have a body like this, and I apply a force. Maybe someone is standing on it like this. This guy will start rotating. Abby, it will move down. It will rotate. The moment it starts rotating, then it's not in equilibrium. But if I put someone else here that will pull it down too, that will counter that rotation, and it's no longer going like this, it's balanced, then you now say it is what? In equilibrium. This guy is applying a force downward. This one is also applying a force downward. These two forces, they make sure this object is not rotating. They will say they are in equilibrium. There is an object on the ground. Someone is pulling this object this way. Someone is pulling this object this way. Someone is pulling it this way. At the end of the day, this object is not moving. All because this one out. Such body is said to be in equilibrium, provided the object is not moving. So we say it is in equilibrium. But before we understand equilibrium very well, the first thing you need to understand is what we call moments. Moments of a force. Moments of a force is defined as the product of a force and its perpendicular distance. Product of a force and its perpendicular distance. If I have a force applied on a load, then for this force is applied this way. So pull this load from one point to another. Let's say I want to cover this distance S. And the force is, the tension in the rope is inclined at angle theta. As I'm pulling that load, if they say I should determine the moments of this load, if you try to do that, resort this down, let's say this is the tension in the rope or the force applied. If you put this rope down and it moves this way, then you are not talking about moments, you are talking about work done. But this line and this line, they are perpendicular, are they? So moment of a force is the product of the force and its perpendicular distance. So this force must be made perpendicular before you solve for moments. And in order to make this guy perpendicular, this place will be f sub y, this place will be f sub s. If you have something like this, f, then this will be fx and this will be fy. But that's not the problem. A lot of you might not know this if you don't know vector. But you know basic mathematics. If this is the angle, this place is also f sub y. In order to determine moments, I don't need f sub x. But in order to determine work done, I need f sub x. Work done is the product of the force and parallel distance. While moment is the product of the force and perpendicular distance. So the force and the distance must be perpendicular. So how do I make this guy to be perpendicular? I can look for this guy. This is opposite, this is hypotenuse. Opposite and hypotenuse is what? Sine. So I can say sine theta is equal to f sub y over f. Fy can be equal to f sine theta. So resolving this now, Fy is equal to F sine theta. So I can say the moment is equal to, this force has become F sine theta multiplied by what? The distance. It must be perpendicular. But if you are given like this, calculate the moment of the force. If this is the distance, let me still use S, and this is the force. In this scenario now, you just say that M is equal to M times S, because both the force and the distance are already what? Perpendicular. Now, that is what we call moments of a force. But moments of a force is not just what we are saying. Moments of a force is the type of force that brings about rotation of a body. That is what we actually call moments of a force. I have this marker, then I want this marker to rotate easily. In order to rotate, I will apply a force. If I apply the force here, then it will rotate. So just look at it. If I apply the force here, and that's why it has to be perpendicular, it's easier. But imagine I apply the force like this. It will not rotate. So the force I'm applying has to be perpendicular to the distance. So as I'm applying the force, it will start, as I'm pushing, it can only rotate. But if I push like this, it will not rotate. I hope you are getting my point. So, applying the force in a way that is perpendicular. So this is the force now. This is the line of action. That is the distance. So the movement is defined as the force times the distance. But so that you can understand the equilibrium of forces, you know I apply the force here to make it rotate. If I don't want it to rotate, I can apply another force here. By the time I apply another force here, it will be equilibrium. But let's leave that for now. We will come back to that. Now, know this formula, which you know how to count, and know the other formula, which is just Fs. Now, we now have some things you hear. You can hear something like coplanar forces. Concurrent forces. Parallel forces. Non-parallel forces, collinear forces, and so on. So the word coplanar, collinear, concurrent, parallel, they are the forces we talk about under equilibrium. Now, if I have a plane like this, coplanar means same. Planar means along the same plane. Concurrent means along the same point. Let me just put it this way. A force acting on this load, a force acting on this load, they are both acting on this same material. So this force F1 and F2 are said to be coplanar because they are acting along the same plane. It is concurrent when they act at the same points. Maybe there's a load on the ground, someone is pulling the load like this, someone is pulling like this, someone is pulling like this. When they act at the same point, we say they are concurrent forces. So just note those terms so that you understand the topic. So when they leave the same point, they are said to be what? Concurrent. Even if they come to the same point, as long as they have a common origin, then we say they are concurrent. A force is said to be parallel when they lie side by side. When they move together side by side, they say it is what? Parallel. Now, collinear, tug of war. They can act along the same line. The word collinear means along the same line. Along the same line. It can be like this in opposite direction, like a tug of war. All of these things will lead us to some things. So as they are pulling the rope now in different direction, we said that the forces applied are said to be collinear forces. These are concurrent forces. These are coplanar forces. And that's what you have. Now, for a body to be in equilibrium, we already know the moments. We now have rules or laws that guide parallel coplanar forces in equilibrium. So there are rules that guide parallel coplanar forces in equilibrium. Now, this force, we have what we call the fulcrum. That is the point of rest of the body. I apply a force like someone sitting on this. I apply a force this way, F1. This F1 will try to make this body rotate. I apply another force, F2. It will try to make that body rotate. I apply another force, F3. Then I apply another force, F4. If I remove F, whatever it is, F3, F4, F2, and I pull this, in what direction will this guy rotate? How will they move? Will they be clockwise or anti-clockwise? Like I remove F2, F4, F3, only this one. When I do this one, in what way will it go? Abi, if I pull this one, in what way will it go? If I pull this one, in what way will it go? All these forces now are said to be coplanar, but they are parallel. Is that taken? So what are the laws that guide them if you have forces like this? I hope you are following. So the rule for parallel coplanar forces is that one, the sum of the forces in a given direction equals sum of the forces in opposite direction. That's one. The sum of the forces in a given direction, if this body will not rotate, as we have said, we don't want it to rotate. The sum of the forces in a given direction will be equal to the sum of the forces in opposite direction. Let's say F3 and F4 are not there. If I pull F1 down and I don't want it to rotate, what will I do? I will pull F2. I hope you are following little by little. Which means that sum of upward force will be equal to the sum of the downward forces. I don't know why some of you, if you are tired, you can go. The answer soon at sum of upward force now, that will be what? F3 plus F4 will be equal to what? F1 plus F2. That's rule number one. If I want to determine the moment of F3, that means the force that is making it to rotate. And that is, in this place now, we say moment is taken as product of the force and the what? Perpendicular distance. But in a situation like this, if I start pulling F3, it will rotate because of where it is. So it will rotate on this axis. So this thing is said to be the fulcrum. Then you take your perpendicular distance to that place. Because if I pull it up, it will start rotating on this guy. Do you get that? So you take this one. If I pull it up, it will go this way. So it will start rotating from here. So let's call this one X3, let's call this one X4. If I pull this one, let's call that one X2. Then from here to here, let's call that X4. You always make your force at the distance towards the point at which it will rotate. So now, the rule 1 states that sum of upward force will be equal to what? Sum of downward forces. Rule 2. Rule 2 states that the summation of the clockwise moments is going to be equal to the summation of the anti-clockwise moments. That's the only way this object will not rotate. Sum of the clockwise moments is going to be equal to sum of the anti-clockwise moments. This is called the principle of moment. Principle of moments. And what does principle of moment state? In a system that is in equilibrium, sum of the clockwise moments must be balancing the sum of the anti-clockwise. That's the only way to not rotate. When clockwise is greater than anti-clockwise, then it will start rotating. So they have to balance out. So now, let's now look for the clockwise moment. For this one, based on this guy, if I pull this one, we already said it. Will it be clockwise or anti-clockwise? F for F1. Because if you pull it down, it will rotate this way. Abi? So you put an arrow. That shows anti-clockwise. For F2, will it be clockwise or anti-clockwise? How about F4? It will go this way. How about this one? So we already said the sum of the clockwise will be equal to what? Sum of the anti-clockwise. So let's analyze that. All of the ones that are clockwise, we said the sum of the moments, the clockwise moments will be equal to sum of the anti-clockwise moments. And what is moment? First times distance, Abi. So the ones that are clockwise, let's do them. F3 is clockwise, Abi. So moments of F3 will be F3 multiplied by what? X3, Abi. Plus sum. Which other one is clockwise? F2 multiplied by X2. That's all for clockwise. Will be equal to F4 multiplied by X4 plus F1 multiplied by X1. That is rule number 2. Are you there? Yes. So let's look at concurrent force. If the forces are concurrent, what do you do? This is the rules for non-concurrent coplanar forces. Non-concurrent means that they are parallel. They do not meet at any point. And that's what happened in these guys. They are non-concurrent. But when you say concurrent, that means they are non-parallel. Non-concurrents are parallel. Concurrents are non-parallel. Because they will meet. For parallel forces, they will never meet. They will both continue forever. But for non-concurrent, no matter where they are coming from, they will have a common, for concurrent, they will have a common origin. That's what we are saying. So, do we understand this first thing? Well, yeah, let's do for concurrent forces. So, what we did now is for non-concurrent. So, for the concurrent forces, so the equilibrium now, we want to know the rules to solve for the rules that guide the equilibrium of concurrent forces. Concurrent forces can apply anywhere, but you need to know one thing. Let's say these are concurrent forces. F1, F2, F3. And you said that these forces are in equilibrium. One thing you know is that some of the upward force will also be equal to some of the downward forces. Some of the forces in one direction will be equal to the sum of the forces in another direction. This is also true. Even though they are meeting at a point. By the time you don't say F1 and F2 now, it should be vectorial sum. Let me put the vectorial sum. The vectorial sum of the forces. Because there are some things we can do here. We can put this line, then put an angle, then resolve this, then that's the sum of the vectorial sum. So, I want you to resolve it by and the day to resolve by. You can add everything up will be equal to everything down. But it will be the vectorial sum of this. If you just say sum of the forces, that means you will say F1 plus F2 is equal to F3, and that's not true. They must be together. But if you resolve this now to go up, if you resolve this, then you can now say the vector sum of F2. That means the Fy now along y and F1 up. That will be equal to F3. But don't just write this first, you will understand what I'm saying. If you are not vector, what I'm saying is that it is. So still leave it for now. I will explain it with time. So just know that the vectorial sum of the forces upward will be equal to the vectorial sum of the forces downward. That is correct. Not the moment. Another thing is that when they are in equilibrium, the vectorial sum of the forces ṣòro àwọn tó ní ká ṣe night class ṣòro ní gbogbo wọn lẹ́yìn ọkùnrin àti obìnrin ló ń ṣeré ìwò wọn wẹ́n pẹ̀lú ìdáná pẹ̀lú wọn rà lónìí. The vectorial sum of the forces along y-axis will be equal to 0. The vectorial sum of the forces along y-axis, you sum all the forces together, taking directions into consideration. You sum all the one up minus the ones down. Everything will be equal to 0. It's just like taking this one here and saying everything you have there minus what you have there is 0. So sum of what is along y and what is down will be equal to 0. Also, the vectorial sum of all the forces along x, we will apply them in solving questions. So for now, still follow. Will be equal to 0. So sum of the forces along y will be equal to 0. Sum of the forces along x will also be equal to 0. And when you have three forces like this, there are two laws you use in solving. There are a lot of laws we can use aside these rules. The first one is called Lami's theorem. Lami's theorem. When you have three forces like this, who are you looking for? Islamia, Olatubosun, Is she a science student or an art student? You don't know. Science. Who knows that? Who knows that? Olatubosun Islamia. Who knows that? So if nobody knows that, maybe she's not a student of practice. So you can tell her. She's in my class. Put in number. For my class, they don't Surely class, you student not start today. They don't have class on Saturday. You know, sharing. Someone not going to the class. Someone will get there. So, Lami's theorem. Hello, please listen. Lami's theorem states that when you have three concurrent forces in equilibrium, the ratio of the force to the angle between the two other forces is constant. When you have three concurrent forces in equilibrium, you already know what concurrent means, having the same common points. When three concurrent forces are in equilibrium, the ratio of the force of one of them to the sine of the angle between the two other forces is a constant. The ratio of the force of one of the forces to the angle, to the sine of the angle between the two other forces is a constant. That is Lami's theorem. In essence, this is what it's saying. Please look up. Are you here? Let's say the angle facing this one is theta 3. The angle facing this one is theta 1. The angle facing this one is theta 2. So, sir, you can tell him to go to the other side. We have them. Maybe they fix the class for them. So listen. Now that we you have this, Lami's theorem states that the ratio of this force over the angle between the two other forces will be constant. So meaning that you can say F2 over sine theta 2, that's the one facing it, will be equal to F3 over sine theta 3, and will be equal to F1 over sine theta 2. So Lami's theorem states that the ratio of the force to the side of angle between the two other forces is a constant. That's what we have here. Is that taken? That's Lami's theorem. When you also have concurrent forces, you can use triangle law to solve the problems. You can use triangle law. You have a body, a wire. The wire, there's a ball hanging. Then you pull the wire, you pull it to around here. Then you now have something like this. And they now told you that this body is in equilibrium. Under the weight of the body is acting downward. There is a rope that is hanging that body. The rope that is hanging that body, let's call it the tension. Then the force that is pulling the body along that line, let's call it. This guy now has three concurrent forces. There's a ball hanging. Now there's a force pulling that ball off, so that it makes an angle with this guy. The ball is hanging just like your picture at home. Then someone goes there and pull the picture with the rope. Then it's now hanging like this, but you did not leave it. And the weight of the picture will act downward. The force you are using to pull it, and the wire that is hanging it. So they now say, they can say calculate anything here. I can use Lami's theorem here if I know these samples. If I know this sample, know this sample, I can use Lami's theorem. I'll just say that W over the angle here, F over the angle here, C over the angle here to look for whatever I'm looking for. But in most cases like this, you are not given all these angles, but you can get the angle. This place now, because this one is horizontal, this one is down, that means this angle will be around 90 degrees. It's only this one you might not know, but you can still know it. If you look at this, this is theta. So if you draw, and you draw this one up, you already know that if this place is theta, this place will also be what? Theta. Do you agree? If that place is theta, that means this place will be 90 degrees. This place will be 90 minus theta. If you draw that line. And this place will be. But that's not the problem. We are not using this at all. We are not using this to solve this. I'm just using it to explain something. There are different approaches. So let's now see how we solve it. If you have a question like this, what do you now do? It is at sample theta. So when you have three forces like this, with the tension and the angle, then you will use triangle law. I'm not assuming you know vector. You will use triangle law when you have this like this. The bodies are in equilibrium. You can use this law here. You can use a lot of things. You can use this law here. But for now, we want to use triangle law. So how do you use triangle law? You will resolve it. I can rub this pattern. Don't worry, I will soon be through. So, what you are going to do in triangular states that if two sides of a triangle represents the magnitude of those the magnitude of two forces in line and directions. A magnitude and two sides of the triangle. Let me analyze this. W is a weight acting downward. F is a weight. F is a force acting this way. And why this is, that's what. So that's what you can do with triangular. When you have the right angle and the two sides of the triangle represents the forces in magnitude and direction, the third part of it will represent the resultant force. But for this one now is the body in equilibrium. There's no resultant here. That's why the arrows are the same, following the same direction. But I don't want to go back to that. So meaning that this angle theta now will now be this place. So you can now solve this one using your Pythagoras theorem. And you can solve it using your Sokatua, I mean, depending on what they say you should look for. So that's what you do with this kind of things. Now in some questions, they can now mix this and that first one together. You just have to know what to do. I will solve some questions with you soon. Very quickly. The next thing you need to know after knowing all these rules is couple. Couple. This was what they asked me to during my exam, although it was scattered. The picture was scattered. Couple. When you have two equal but opposite forces, F1, F2. If you are driving a car, one goes down, one goes up when you are turning. The two cannot go like this. When you are turning something, one goes down, one goes up. Then you can rotate it. Then between a distance. So if they now say you should calculate the moments of the couple. Moments of a couple is product of the force, product of one of the force and the perpendicular distance, and that is called torque. Yeah. I'm almost through. So there's what is called torque. Torque is defined as moments of a couple. And what is moments? Force and the perpendicular distance. But now, note something. F1 is equal to F2 in the couple. The forces are the same, but their directions are what? Different. Is that thinking? In the couple, F1 will be equal to minus F2. So they are the same in magnitude but opposite in direction. So now to get it, you just use one of the forces. So the moment of a couple is going to be one of the force, F1 times the distance, or F2 times the distance. You will still get the same answer. That's what you do for couple. The next thing is center of gravity. COG. Center of gravity. It is the point at which the entire mass of your body seems to act, or the entire weight of your body seems to act. So where it seems as if where the entire weight seems to act, that is what we call center of gravity. Where the entire weight of the body seems to act. So every object that is balancing as a center of gravity. So for regular objects, if we want to determine center of gravity, we use regular objects and irregular objects. It is not easy to know the center of gravity of an irregular object. So to know the center of gravity of irregular objects, please, you will draw a line. If it is a ruler that is 100 centimeters, the center of gravity is at the center of the ruler. And that is at 50 centimeters or 0.5. That's 0.5 meter. Okay? Times minus 2. Yes. That's 50 centimeters or 0.5 meter. That's the center of gravity of a metal roof. If they give you a circle, and they say that where is the center of gravity of that circle, this is a circle now. You will draw line down. So where the lines meet, that point where they meet is known as the COG. I hope you are following. If I say, you are not written this. If I say where is the center of gravity of a triangle, where would it be? You will draw a line like this. You will draw a line like this. Draw a line like this. So where they meet, that is the COG. All those are for regular objects. If you have a rectangle and you say that where is the center of gravity, you will draw a line like this. A line like this. So that is the COG. Are you there? Now, quickly. For an irregular object, just know that in order to determine COG for an irregular object, we use what we call non-blind method. Non-blind method. That's what you use, non-blind method. So, that's what you have. Now, types of equilibrium. For the types of equilibrium, we have what we call stable equilibrium, neutral equilibrium, and unstable equilibrium. The body is said to be in stable equilibrium if it comes back to its original position after being displaced. The body is said to be in equilibrium when it comes back to its original position after slight displacement. And what are the things you need to know for a body in stable equilibrium? It will have low COG. It must have low center of gravity. It must have a wide base. So if a body is in stable equilibrium, let me just use diagram to quickly explain the thing. For stable equilibrium, an object like this has a wide base. With the wide base, it is stable. If I push this object a bit, by the time I push this object, it will fall back. Because if you do like this, you will see that it has a very low center of gravity. So an object is said to be in stable equilibrium when it has low center of gravity. Is that thinking? Now, if an object has low center of gravity, you will say that an object is in stable equilibrium if the potential energy increases. Because of the low center of gravity, the potential energy decreases because the height. If the potential energy is high, then it will not be balanced, it will fall off. But because the center of gravity is low, so the potential energy decreases. And that's why it will always be balanced. An object will always tumble. Let's look at neutral. An object is said to be neutral if it's lying down like this. So if you tilt this guy, no matter how you push it, I don't know how, you understand what I've done? I put the side of this guy on the floor. So when you tilt it, it always rests on that side. It will not take a new position. So this one is said to be neutral. Let me give you another example here. This is simple. They asked me this question. This is neutral. That's neutral, because if you push it, it will not be as if anything is happening. But if you drop this one up, it will fall back again. So it's remaining in its position, even after displacement. But for stable, you have a body like this. So a body standing on its pole, a cone standing on its apex is going to be unstable. What will happen to such body? It will fall easily because the center of gravity is very high. It's very high. And if it has a high center of gravity, and if it has a high center of gravity, potential energy will be high. High potential energy. And if it has a potential energy that is high, if you just tilt it like this, it will fall down immediately. That's what you're talking about. So that is unstable. So note these things. You will see questions on them. So that's unstable. This ball now will be unstable like this. It's just waiting for something to touch it so that it can explode. So a human being that is unstable too will be like that. Marshall your joint. So any small thing like this will explode. Who can one to my ignited? It's highly reactive. Such people will not be highly exalted. They have too much potential energy. But their potential energy will be used wrongly. They are always looking for you to come to them for trouble. So that's all. Past questions. All questions. So let's So look at this question. That's one. So please, these are questions. Let's quickly solve these questions before we go. You need to know how to solve questions. Yeah. All those stories I've seen this morning. If you don't know how to solve questions, it's a waste of. So listen, this one states that F1, F2, 100 units. I don't know why you will still give me this question. With this kind of setup, how can we? They said we should solve for F1 and F2. Out of all of the laws and rules I gave you, which one can we apply here? We can apply that theory. So that means if this is 60, this is 150, what will this place be? Everything will be 360 at the 150 plus 60. 350 minus 210. 1. This is also 150. They now say we should look for F2 and F1, but you know this one. So you can say F2 over sine 150 is equal to, since you don't know this, you can't use that one, is equal to 100 over sine 60. Sine 150 is also equal to what? Sine 30. Is that correct? In negative. This one is 50. This is sense. Are you there? Do you understand this now? Can we solve for F1 now? So F1 is going to be over sine 150. I think it should be the same. 100 over sine 60. So F1 and F2 will be the same. Is that clear? Oh yeah, let's look at the next question. For this one, they said if the system is at equilibrium, the values of T1 and T2 are. Now, you have two forces here. For C1 and C2, the angles they made with the verticals are different. Now, in solving this problem, there are different ways you can solve this. There are different ways. You can do what I did the other time. You can resolve the two T2 and T1 to the vertical and equate it to 100. But T2 is not the same as T1. Why won't it be the same? Because the angles are different. So in order to solve this, we will do two things. We can also use triangle law. Shake it. Let me just check that one first. But it's not supposed to be that 100 Newton. This space is supposed to be. That's outside, child. So, which one is this one? 100. So you can break it into two. You can just solve it this way. This place will now be 50 Newton. Then this place is 45, so I have to look for T1. So if you look at it, this will be hypotenuse. So this will be hypotenuse, this will be opposite, this adjacent. So I can say cos 45 is equal to adjacent 50 over hypotenuse T1. So T1 can be equal to 50 over cos 45. And cos 45 is 2 over 2. So that can be 100 over 2. Is that the option? 100 over 2. We can resolve it. Okay, the cos is there. Cos 45 is going to be 50 times 2 over 2. Then you do solve. That's going to be 100. Yes? 200 root over 2. Cos 45 is also root over 2. But it's below. The next 1 over cos 45. It's like now 50. So it's now becoming 2 over 2 because of this. So now 50 roots is going to open. How will that right is shadow. So you will read the you want to do a job fast. That is huge for Please, another way you can do this is this. You will do a lot of maths here. That means you start trigonometry. You will do the functions of cosine in relation to cos. Here now we will have this. You can first do that. If you don't want to do this, you can first do this. Then you trace this one up. If this place is 45, this place will be 45. If this place is 60, this place will be 60. Then this place will be 30. This place will be 45. So you will now take this one to the vertical, to the horizontal. You will now use this rule that says that sum of Fy equals 0 and sum of Fx equals 0. Or sum of upward forces equals sum of downward forces. So that's how you will do that one. So let's see how you will do it. So you will now say that to take it to the vertical, you use this angle. So that will be C1 sine 45. That's for the Fy now. C1 sine 45 plus C2 sine 30, okay, equals 100. Abi, but we don't know T2, we don't know T1. And we can also do for the down. So we can say for the other side, we can say for the Fx now, we can say T2 cos 30 is equal to, or yes, is equal to T1 cos 45. So we can start equating. We can make T2 or something the subject of the formula. T2 is going to be T1 plus, and that's why you are using trigonometry. It's going to be cos 45 over cos 30. So T1 sine 45 plus C1 cos 45 over cos 30 equals 100. So this is cos 45 cos 30. And this is sine 45. So okay, this is T1. If I find the LCM, it's going to be a lot of money. But this is going to be T sine 45 plus C cos 45. Abi. But there should have been people that were also sorry. Aside the one I'm calling. So you start thinking about what can we do, what can we do. And the angles are really strict because we have to resolve what is 45 to maybe a lot of things. And inside that day to this one. side is none of their own. And this is their own. It's not cosine. It's cosine. But you cannot. The same thing to do, so we don't continue to say as part of the process. But now say cosine 75. Remember, what we have done here is correct. But just trying to do it this other way is going to be solved. So let me sit down one quickly. Ready? So this one says that what is the tension for the clockwise movements? What is it? So for this, what kind of thing is this one? Let me just assume that what you meant, because what I'm giving is this. 0.5 kg, 40 centimeter. 60 centimeter. 30 degree. 90 So, I don't know what we're actually looking for here. But the same should look for tension. So the thing here you can do is that this 0.5 is actually the weight. The distance from here to here is probably 40 centimeters. So this one will be 50 meters. Like the weights, 50 meters. Then you will resolve this one to the vertical so that you will standing as C1. So the person asks the question. So that becomes T1 because it has to be perpendicular to the distance. So you now take it to the and you take this one. This one is saying that from here, maybe from here to here, I don't know. Let's say, I don't know, you didn't draw the diagram well. But so let's just say from here to here. From here to here is from the beginning, from here to here is probably 40 centimeters. Then from here to here is 60 centimeters. Then from here to here is 90 centimeters. So I'm taking everything to this guy. So if I take 50 into now, what will be from? What's 5 minutes? Okay, 5 times 10, that's 5 minutes.
That middle place is 60.
Then that's just the block of assist is suspended at 40 centimeters. So that means from here to here is 40 centimeters. That is suspended at 90 centimeters. That means from here to here is 90 centimeters. That's what I'm saying. And it's get that equilibrium by a string attached at D. By a string attached at D. So this
Why the food
So in order to solve this now, this CY. So CY Y will be equal to CY will be equal to C sin x. So clockwise movement is equal to sum of anti-clockwise movement. So this is anti-clockwise, this is. So this will be 5. If from here to here is 40, and from here to here is 90, and from here to here is 60. So now we 5 times 80. From here to here, that's if from here to here is 60, and from here to here is 90, that will be So to those of you talking about ninth class, I wish, I'm sorry. So those of you that gave this is a simple question. Find the magnitude of the force. Resolve it to the horizontal and solve it. This is your problem. Which matter are you resolving? Some of you are not serious. There's nothing we can do. We can't do night class now. So I will just advise all of you to please, your exam is next week. Go and read. I don't know why you want me to address some things in class, because you have no sense at all. So you can go ahead to do what you want to do. So please, those of you that have been reading, I pray that God will see you through. Focus on your exam. You have no reason to fail. Some people are not here to succeed. But you focus on your life and succeed and do well. You are here for a purpose and you have been working hard. So please, I will tell you 5 things to do during and after your exam. So I'll try and work on that. So as much as possible, please, let's do everything on our parts to make things work well. God will see you through. And will know when you exam. So bye-bye. Say hi to your parents. You can go if you have. How are you? If you go,